Welcome back, everyone, for another deep dive. This time we're going billions of miles away to catch up with Voyager 1. You know Voyager 1, right? Humanity's farthest spacecraft. It's been cruising through interstellar space for almost half a century. We've got some really cool source material on Voyager's recent communication problem. And its amazing recovery. It's a story about dwindling power, really ingenious engineering, the amazing science this little probe is still doing out there.
It's a story that shows just how tough these spacecraft are and how clever the people who built them were.
It really is amazing. You know, Voyager 1 was launched in 1977, and it's using technology that seems so old now, yet it's still out there, exploring where no one has gone before. But keeping a spacecraft working at that distance, it's not easy. In fact, Voyager 1 recently gave the team at NASA a real scare. And unexpectedly switched from its main transmitter, the high-power one, the X-band transmitter, to a much weaker backup, the S-band transmitter.
And that meant scientists back on Earth, they were suddenly in the dark. No scientific data coming in, no status updates, just silence from billions of miles away.
I can imagine that was a bit unnerving, to say the least. Especially when you think about how far away Voyager 1 is, 15.4 billion miles. That's so far that even at the speed of light, commands take over 22 hours to reach it. And then, of course, another 22 hours to hear back.
Wow.
Yeah, troubleshooting at that distance. It's like trying to fix something incredibly tiny from really, really far away.
It's hard enough to fix things here on Earth. Yeah, that must be a real challenge.
So what caused this switch to the weaker transmitter? Did something actually break?
Not really. Voyager has a built-in safety net. It's called a fault protection system. It's meant to prevent a total failure. If the spacecraft senses it might be running out of power, it automatically switches to low power modes.
So Voyager essentially went into power-saving mode. Kind of like when your phone dims its screen to save battery?
Yeah, that's a pretty good analogy. And the team at NASA, they've already turned off all the non-essential systems on Voyager to try to save power. They've even had to turn off some of the heaters for the science instruments, which means they're exposed to the extreme cold of interstellar space.
That sounds a little risky. Weren't those instruments designed to work within certain temperature ranges?
They were, but what surprised everyone was that the instruments continued to work, even at temperatures way below what they were tested for.
Wow.
Yeah, it really shows you how well built those instruments are.
That's remarkable. So they were tough enough to survive out there. But managing the power on a spacecraft so far away, it must be incredibly difficult.
It is. The engineers at NASA, they're constantly calculating power budgets and making decisions about which systems to keep running. They've gotten to the point where they're measuring power in fractions of a watt.
Fractions of a watt. What does that mean for how they manage Voyager?
It means every little bit counts. It could mean having to choose which instrument to turn off. Knowing that means you might lose data about the universe. Every watt they can save allows them to keep another instrument running. They're trying to get every last bit of science out of this incredible mission.
Wow, that's incredible. It really highlights how dedicated the Voyager team is.
Yeah.
They're constantly coming up with these creative solutions just to keep this mission going. But it's not just about keeping the lights on, is it? We should talk about the science Voyager is still doing. It's amazing to think that 4 of the original 10 scientific instruments are still working. What are they measuring out there in this totally uncharted territory?
Well, Voyager 1 is exploring interstellar space. That's the region between the stars. It's full of particles and plasma and magnetic fields, all the stuff that came from other stars and supernova explosions. Voyager's instruments are measuring all of that. It's giving us a look into this region of space that we've never been able to explore before.
Hold on a second. Interstellar space. Doesn't that just mean the space between stars? I think we need to explain that a little bit.
Sure. A lot of people think that interstellar space is just empty, but it's actually not. It's filled with matter. Though it's much less dense than the space in our solar system, it's kind of like a thin soup of particles and radiation. And Voyager 1 is the first thing we've ever sent out there to actually sample this soup and tell us what it's made of.
Wow. So Voyager is sending back data. That's changing how we understand what's beyond our solar system. What are some of the biggest discoveries so far?
One of the most important discoveries is that the interstellar magnetic field is way stronger than we thought it would be. And this is important because it helps us understand how stars and galaxies form. And Voyager has also detected waves in the interstellar plasma. We think these waves are caused by shock waves from really distant supernovae. It's like we're listening to the echoes of these ancient cosmic events.
That's amazing. How do scientists actually make sense of all this data? It must be like trying to decipher a message. in a language you're just starting to learn.
You're right. It is a really complex process. It takes experts in a lot of different fields working together. Physicists, astronomers, engineers, even computer scientists. They have to analyze the signals from Voyager, which are very faint. Then they have to filter out all the noise and calibrate the instruments to make sure the readings are accurate.
There must be a lot of double-checking and verification going on, especially with the huge distance and the communication limitations.
Absolutely. The team has to be incredibly careful, and they have to be really creative in how they interpret the data. They're constantly developing new algorithms and techniques to get as much information as they can from the little bandwidth that's available.
It's really a testament to human ingenuity. But this brings up a question. How long can this actually go on? Won't Voyager eventually run out of power completely?
It's definitely a race against time. Every year, Voyager 1 loses another 4 watts of power. The team is doing everything they can to save power, but eventually they're going to have to make some tough decisions about which instruments to keep running and which ones to turn off.
I read that they already had to turn off one of the instruments on Voyager 2 this year, just to save energy. That must have been a difficult decision.
It was. Voyager 2 is facing the same power problems as Voyager 1. The engineers had to choose which instruments were giving them the most important data at this point in the mission.
So every decision they make has consequences. What other challenges are coming up for the mission?
Well, as the power supply keeps getting lower, the team is going to face even bigger challenges. They'll need to constantly adjust the voltage monitoring to keep the power stable to the instruments. And they'll have to find new ways to deal with the fact that the components are getting old. Plus, they'll need to develop new strategies to handle the technical problems that keep popping up, which is bound to happen when you're dealing with a 50-year-old spacecraft in a harsh environment like interstellar space.
So Voyager 1 is facing some real problems, both with power and technical challenges. But knowing how ingenious and dedicated the team is, I bet they'll find ways to keep it going for a while longer.
I agree. They're really pushing the limits of what's possible. They're constantly coming up with new ideas to overcome these obstacles.
So we've talked about the power struggles and the incredible science that Voyager is still doing and the dedication of the team that's keeping it alive. What does all of this tell us about the future of the mission?
Well, to be realistic, we're getting close to the end of an era. No one knows for sure how much longer Voyager 1 will keep transmitting. But as its power runs lower, it's clear that its time is limited. It's a little sad to think about. But Voyager's legacy will definitely continue to inspire people.
A legacy of exploration and discovery, and the never-give-up spirit of humanity. That's a great lead-in to the final part of our deep dive. We'll be talking about the impact of the Voyager missions, how they've changed our understanding of the universe, and the big questions they raise about our place in the cosmos. And it really is kind of poetic, this little spacecraft, traveling farther than anything we've ever built, still sending back this data across billions of miles.
Yeah, it's really something. And as Voyager 1 gets closer to the end of its mission, it's worth thinking about the incredible impact it's had, not just on science, but on how we see ourselves in the universe.
Yeah, for sure. And speaking of impact, we can't talk about Voyager without mentioning the pale blue dot photo. You know that picture of Earth? Taken by Voyager 1 back in 1990 from more than 4 billion miles away.
Oh, yeah.
Earth is just this tiny little dot suspended in a beam of sunlight.
That's a powerful image. It really makes you think about how fragile our planet is.
Yeah, it's humbling. And of course, Voyager isn't just sending back pictures. We also have to talk about those golden records. On board both Voyager spacecraft.
The golden record.
Yeah. They're like time capsules of humanity, full of sounds and images from Earth. They're meant to be a message to any aliens out there who might find them someday. Wow. They've got greetings in over 50 languages, music from different cultures, sounds from nature.
It's amazing to think about that those records could outlast us, just drifting through space long after we're gone.
It's like throwing a message in a bottle into the vast cosmic ocean. You never know who might find it.
That's a great way to put it.
I wonder what future civilizations will think when they find Voyager 1. Maybe millions of years from now.
Who knows? Maybe it'll be humans who find it. Maybe it'll be something else entirely.
It'll be a relic of our time, a reminder of when we first started, reaching out beyond our world.
I wonder if they'll understand what it is, if they'll be able to figure out the golden records.
That's a good question. What will it tell them about us?
It's hard to say.
But I think one thing is for sure. Voyager 1's story. It's a testament to human ingenuity, our desire to explore, and our need to understand the universe. Even with all the challenges, we keep pushing the boundaries of what's possible.
I think that's a great way to sum it up.
So as we wrap up this deep dive, I want everyone listening to remember to keep looking up the stars. And remember Voyager 1, that little spacecraft, carrying our message of hope and wonder across the vastness of space. And as we continue to explore the universe, let's all be inspired by Voyager's legacy, to never stop asking questions and to never give up on the pursuit of knowledge.
Well said.
Thanks for joining us for this incredible journey. We'll see you next time for another deep dive.